Let's start by reviewing an example from the What is an Equation video. In the example, we saw that 2x was equal to x plus x, and we thought of this as having two x's. Similarly, we could think of 5x as having 5 x's. And then we asked, what is 5x minus 2x? So we had 5 x's, we subtracted 2 x's, and we were left with 3 x's. And we try to visualize this idea of adding things, adding x's, by just thinking of a present. A variable is just a number in disguise. We gave it a different disguise here. It's just a present. So 2 times present is equal to present plus present. So we had 2 presents. Similarly, instead of 5x, we had 5 presents. And in the same way, we saw that 5 presents minus 2 presents left us with 3. So this idea of a variable just being a thing and that we're just adding and subtracting things, that's going to be really important in this video. So let's continue with this idea in the next example. Here, instead of 2x, we're going to look at 2 times x to the third power. And this is equal to x to the third plus x to the third. So similarly, we can think of this as having 2 x to the thirds. And let's take a look at that x to the third right here. If x is a number in disguise, isn't x to the third power just another number in disguise? So let's think about that. X to the third is a different number in disguise. X gives us one number, x multiplied 3 times gives us a different number. So using our present example, we can represent x to the third with a different present. So we'll have 2 times present, but this time we're looking at x to the third, so let's make it a different color. So we have a different present here. So 2 presents equals present plus present. So now we have 2 purple presents. And let me ask you, what is 5x to the third minus 2x to the third? Well, that would mean we'd have 5 purple presents minus 2 purple presents, leaving us with 3 purple presents, or 3x to the third. And that's our answer. So that's what this video is about. We started with our original present, and now we're just going to expand it a little more so we have different kinds of presents that we can add and subtract. So let's keep practicing this with a new example. What is 5x to the third power plus 4x minus 2x plus 3 times x to the third power? So let's try to simplify this. Instead of x, we're going to have our original present. We'll substitute that in. And instead of x to the third power, we're going to have our purple present. So we can rewrite our problem as 5 times purple present plus 4 times our green present minus 2 times our green present plus 3 times our purple present. So we're just adding and subtracting things, and we want to know how many purple presents and how many green presents we have overall. So let's rewrite this to group our presents together. So we'll have 5 purple presents plus 3 purple presents, just rewriting this. And then we'll have 4 green presents minus 2 green presents. All right, we've gathered our similar presents together. Now we can simplify in our final step. So 5 purple presents plus 3 purple presents leaves us with 8 purple presents. And then we have 4 green presents minus 2 green presents. That leaves us with 2 green presents. And there you go. We have 8 purple presents and 2 green presents. And we said that our purple present was x to the third, and our green present was x. Let's try another example. What is negative 4x plus 2 times x to the second power minus 7x plus x to the second power minus x to the third power? Instead of using presents this time, I'm going to color code this problem just to give you a different way to look at it. Hopefully this makes the problem a little more clear. We've got some x's, some x squareds, and an x third at the end. So let's rewrite this problem, again, grouping the similar items together. So we have negative 4x minus 7x plus 2x squared plus x squared minus x to the third. Negative 4x minus 7x leaves us with negative 11x. And then 2x squared plus x squared gives us 3x squareds. And we have a minus x to the third at the end. Just a quick note before we move on. X to the third is commonly called x cubed. And that's because x multiplied 3 times gives the volume of a cube where each side is of length x. Similarly, x to the second power is called x squared because x times x gives the area of a square where the length of the side is x. So these are just little nicknames we have. X to the second power and x to the third power show up quite a lot in math. And so the fancy math folks, they just got tired of saying x to the second power and x to the third power. So they just came up with x squared and x cubed. Just a quicker way to say it. Before moving on to our final example, I have a little mini example I'd like to walk through. In this mini example, I'd like us to see how we can write a problem in more than one way. So let's look at 3 minus 7. So we know that 3 minus 7 is equal to negative 4. So 3 minus 7, I want to write that a different way. So I'll write it as 3 plus negative 7. Well, 3 plus negative 7 is equal to 3 minus 7, which is equal to negative 4. So we just rewrote our original problem in a different way. And let's do that one more time. 3 plus negative 7 can be rewritten as 3 plus negative 1 times 7. And this equals 3 plus negative 7, which equals 3 minus 7, which equals negative 4. So we can see that 3 minus 7 can be rewritten in a couple of ways. And this might not really seem that important, but as we get into our next example, you'll see why I brought it up. What is negative 6x squared plus 4x minus the quantity 2x squared plus 5x minus 13? All right, how do we subtract an entire piece that's in parentheses? Let me rewrite the problem to make it a little more clear. Negative 6x squared plus 4x plus -1 times the quantity 2x squared plus 5x minus 13. Is that the same thing? Let's connect it to our example above. So we're subtracting this piece here minus this piece here. And similarly, in the example above, we had 3 minus 7. So it kind of matches that similar format, right? And in the example above, we saw that 3 minus 7 could be rewritten as 3 plus -1 times 7. So that's kind of what we did here. This right here is our 3 again, and we just added -1 times 7. And now we can see that this -1 piece, we can just distribute to each piece inside the parentheses. So let's go ahead and do that. We have -6x squared plus 4x plus -1 times 2x squared plus -1 times 5x minus -1 times 13. Let's keep going. I'll keep it all one color now. We have -6x squared plus 4x plus -1 times 2x squared is -2x squared plus -1 times 5x is -5x minus -1 times 13 is -13. That leads to -6x squared plus 4x. We have plus -2x squared, or we can just say minus 2x squared plus -5x, or just minus 5x, and minus -13. How do we subtract a negative number? Well, if you notice, you can actually rewrite it. Minus -13 is the same as -1 times -13. Well, how does that make sense? How does minus a number equal -1 times that number? Well, we saw that in our mini example. We started with 3 minus 7. And as we worked down the page, we saw that 3 minus 7 was equal to this piece right here, where it's -1 times 7. So minus a number is -1 times that number. So minus -13 is equal to -1 times -13, which leaves us with plus 13. All right, let's keep going. We're almost there. So we have some x squareds that we want to put together. We have -6x squared minus 2x squared plus 4x minus 5x plus 13. -6x squared minus 2x squared leaves us with -8x squared. And then we have 4x minus 5x. That leaves us with -1x, or we can say minus x. And we have a 13 at the end. That is our answer. One more thing before we move on. When you have a problem like this, where you're subtracting a piece in parentheses, oftentimes in class you'll hear your teacher say, just distribute the negative. And I wanted to do this example so that you understand that we're actually distributing a -1 because we can rewrite the problem in that way. So it's kind of a shortcut to think about distributing the negative, meaning multiplying each piece inside by a -1. And I just wanted to make sure that you knew where that came from. Because sometimes in math, you can get in the habit of following rules or tricks, and you might not really understand where they come from and what they mean. The purpose of this course is for you to understand what math means. Where do these things come from? The way for you to become a more critical thinker is pretty simple. If you don't understand something, ask questions. Ask, why is that the case? How does that work? Can you give me an example? How does that connect to an earlier idea? This process of searching for a deeper understanding, that is what it means to be a critical thinker. And on that note, I'd like to wrap up with some vocab. In our box here in pink, each of these pieces that's separated by a minus or plus sign, each of these is called a term. That's the fancy math word for it. Not too fancy. So each of these is a term. So we have a term minus a term plus another term. Our answer in the pink box is an expression. And we've said in a previous video that an expression is some combination of variables and operations, and that's what we have in our pink box. However, when you have more than one term in your expression, there's a special name for it. It's called a polynomial expression, or just polynomial for short. And again, that is an expression that has more than one term. And the poly part of the word, that means many. So when you see polynomial, another way to think about it is many terms. It is an expression that has many terms.